Welcome back, y'all. This is going to be a short video as it's very similar to my last one. I'll be making sodium nitrite from sodium nitrate and lead. There will be a few differences from the potassium nitrite prep shown in the last video. Temperature control is more important for the sodium salts because of their lower decomposition temperatures. I'll be adding the lead in portions to the molten sodium nitrate, waiting to add more until it fully reacts instead of mixing the whole of both reactants before heating. After extracting the reaction mixture afterwards with water and filtering, I'll bubble CO2 through the filtrate to precipitate any dissolved lead, but not hydrogen sulfide after that. Most of the lead is removed by the CO2 alone, and I think the rest of it precipitates after boiling it down a bit. If not, the alcohol treatment removes the rest. I followed a different source, which is why it's different than the potassium nitrite procedure. The sulfide contamination from the hydrogen sulfide bubbling gave the N-potassium nitrite a sulfury smell. Not rotten eggs sulfury, more umami-ish if that makes sense. It's not pleasant, but it could be so much worse considering the source. I'd prefer it didn't have the smell because potassium nitrite shouldn't smell like anything when it's pure. After bubbling CO2 through it, I filtered it as before, and added a very little dilute nitric acid to the filtrate until it was neutral to pH paper. The procedure didn't specify the concentration, so I added a few milliliters of 93-ish% nitric acid prepared from concentrated sulfuric acid and potassium nitrate to distilled water to make 200 milliliters total, approximately. Of this 200 milliliters, it took 100 milliliters to neutralize the sodium nitrite solution, so maybe I made it too dilute and it could have been somewhere closer to like 5 or 10% instead of like 2%, which is roughly what I made. Truthfully, I don't know the purpose of the neutralization, but it said to do it, so I did it. In the procedure for preparing potassium nitrite, at the very end of it, it says that when it's required for use to dissolve one part of it in 2 parts of water, cautiously neutralize it with acetic acid and filter it. So it's common to neutralize it in both, it's just when it happens that's different, and what they use, I guess. If you know why it's necessary, let me know in the comments. After those differences, the purification is almost the same as before, but I used sodium hydroxide pellets in my desiccator instead of concentrated sulfuric acid. I didn't spill any in my desiccator this time, so it probably didn't make that much of a difference in drying it, but it's better to be safe than sorry. I'll be ripping through the preparation, but you'll get the general idea, and I'll try to fill in most of the blanks in the voiceover. If you don't find this sufficient, watch the potassium nitrate video for the detailed but slightly altered procedure. On to the video. Here's me torching the sodium nitrate and adding the lead in portions. The reaction is a bit more vigorous due to the higher rate of thermal decomposition of both sodium salts, in addition to the exothermic nature of the reaction itself. And here is my elegant extraction of the product mixture as before. The difference in temperature of the reaction caused the lead oxide produced to be less yellow and more red than it was for potassium nitrite, which I'll show later. Here's the filtrate, not quite neon yellow like it was for potassium nitrite. I skipped filming the CO2 bubbling, boiling, and filtration, but it looks almost identical to the initial filtrate. Now I'm adding dilute nitric acid, boiling it down a bunch, filtering it again, and I'm pouring the resulting roughly 75 milliliters of it into 200 milliliters of denatured alcohol. I boiled it down, filtered it, boiled it down, added alcohol, boiled it down, filtered it, and so on. I got 4 crops of the end product, the second and fourth crops of which are slightly yellow. The second crop is likely because I didn't wash it on the filter with enough alcohol. The fourth crop, it's the last crop, so I kind of expect it to be slightly yellow. Besides, it's not uncommon for sodium nitrite to be slightly yellow. Here's what I got. Crops 1, 2, 3, and 4 in those amounts. And in total, 49.18 grams. And again, assuming 100% purity, this represents a 71.28% yield, which is just over 1% less than the yield I got for potassium nitrite. Again, I'm very happy with this yield and slightly less happy with how violent the reaction was. However, I think the more violent reaction conditions are worth it given how much more convenient sodium nitrite is to use than potassium nitrite. As for the lead oxide, it's a little more than 10 grams over what it should have been, maybe because of lead 4 oxide contamination, maybe because I suck at chemistry, but most probably it's because the stuff was still wet when I weighed it. Who knows? The lead oxide is just a side product, so I don't really care that much. You can see a little unreacted chunk of lead in the form of a solidified puddle, so I'm curious if I added the lead too quickly, and with better control of the additions, the yield could be bumped up to 75 or 80% or even higher. The thermal decomposition might prevent this though, so maybe not. I'm still waiting on one chemical to come in the mail for titrations, so I did the qualitative test like I did for potassium nitrite. All 4 crops gave positive results, even the 4th crop, which is good. The 4th crop, again, it doesn't look great, but it checked out. That's about all I've got. If you want to, like, comment, and or subscribe, and I'll see you in the next video. I also do welcome recommendations for experiments, so just pop them down in the comments.